Ladies and gentlemen, many of you were here last night for the MIT versus Mars One debate, and Bas Lansdorp, CEO of Mars One, is here to present latest information about Mars One. Welcome, Mr. Lansdorp.
Thank you, thank you. So before I start talking about Mars One, I really want to say thanks to Jill Levin for a really nice presentation. The Apollo missions is one of the things that have inspired me to start Mars One, but the Viking missions are the other one. I am so impressed that these things were happening in 1975, and I'm sure that all of you have been there, but if you haven't been to the Smithsonian, if you haven't seen the Viking lander yet, go there and look at it, and to me it's so amazing. I studied mechanical engineering, and you know those old green drilling machines and things like that? That's what the Viking lander looks like, and it's so impressive to me that was sent to Mars, that it did all these things so long ago. Really cool. So, pleasure to meet you. So, I'm not going to tell you all about the Mars One plan because most of you will know most of that already. I want to focus on two specific points. One is why one way, and the other one is the journey. So how are we going to get stuff from Earth to Mars? So very briefly, for people who have not been to our website, who don't know our plan, we want to send humans to Mars in 2027 on a mission of permanent settlement, one way. A number of robotic missions before that, a demo mission in 2020 based on the Phoenix lander, 2022 a rover that will pinpoint the location of the outpost, 2024 all the hardware for the outpost, 2026 human departure and departure of the hardware for crew number 2, landing in 2027. So the crew finds a habitable outpost where they can go and live. And instead of trying to bring them back, we keep sending things every 2 years. Now, I want to reiterate why I believe it's crucial that we take the permanent settlement approach, the one-way mission approach, because I believe it's the only way that we can go to Mars in my lifetime. So the most important reason that I can think of is the risks involved with the return mission. Launching rockets is difficult. Between 1990 and 2014, 126 satellites did not reach their correct orbit. Either the rocket exploded or they ended up just in the wrong orbit. Well, if you're launched from Mars and you end up in the wrong orbit, you might as well have exploded on the launch pad. So launching rockets from Earth is difficult. About 5%, 10%, depending on where you look. Now imagine a rocket that has traveled to Mars for 7 months, that has gone through re-entry, that has been on the surface for a couple of years with no supervision. Maybe you refuel it there, maybe it's fueled, however you would do that. Then 4 people go to Mars, or however many in the case of the return mission. They're on Mars for 30 days, which is not nearly enough to check out the rocket, or for a year, which is not nearly enough to check out the rocket because hundreds of people do it here on Earth. And then they're supposed to climb into that rocket and launch without testing the rocket unmanned? I don't think so. So maybe you would have to do all that without humans on Mars. Even more difficult. Hey, you'd have to do that before trying to send humans back. You'd have to do a complete fake manned mission without the humans. Backups. Backups are important. I see the return mission as the greatest risk for a many number of reasons. So, single points of failure, another very important reason. Every Mars mission that I can think of will have single points of failure. For example, the transit vehicle. It's crucial that you retain, for example, an atmosphere in the transit vehicle. Though I don't see how you can completely eliminate all single points of failure from the transit vehicle. And entry, descent, and landing. Entry, descent, and landing is also always going to be a single point of failure. That's for the once humans land on Mars, they will find a habitable settlement there, and then it's much easier to have backups, redundancy. In our case, for example, the hardware for the second crew that's coming to the already redundant base. Now, then you try to send humans back. So the launch is a single point of failure. Hey, why didn't I tell you that the launch from Earth was a single point of failure? Because there you probably will have a crew escape system during in case of a launch abort. Well, can't you have that on Mars? Well, if you're aborting from a launch on Mars, then where are you going to go? And if your outpost was able to sustain you for another 2 years, then why not stay for another 2 years in the first place? Which is what I would do if I were there. Then there is either another maneuver in space, which is a single point of failure, or a docking, depending on whose mission you pick. Then there is another transit, and then there is landing on Earth. A lot of additional single points of failure that you will have in the case of a return mission. So, another very important reason for staying on Mars is the human body. There's 2 reasons. Radiation. I don't think that radiation is a showstopper for Mars. If you go there, you get about 400 millisieverts. If you go back, you get another 400 millisieverts. That's okay, right? I mean, it's well within what we allow even for low Earth orbit astronauts. But if you don't go back, then you don't get additional 400 millisieverts. So it is safer to stay. If you cover your outpost, if you limit the amount of hours that people stay on the surface, then you will reduce the amount of radiation compared to a return mission. But more importantly, the effects of zero-G. If you go to Mars, you'll lose bone mass, you'll lose muscle mass, and when you land, you will be a weaker human. But that's okay, because you're actually going to a planet with a weaker gravity. Then you spend however long you want to do in the case of the return mission on Mars, and you launch, you survive all those single points of failure, and then you have to do the re-entry at Earth. You've been weakened on the way to Mars, you've been weakened on Mars, you've been weakened on the way back, and now you want to survive the highest velocity re-entry ever done by a human. That's difficult. So artificial gravity, of course, these things can be solved, but it's additional engineering challenges that you put into your mission. Of course, there's a very big question mark for the permanent settlement mission. What happens to the human body in 40% gravity in the really long term? We don't know. So another very important reason for permanent settlement is that for the return mission, you need a much larger infrastructure. So a lot more hardware to go there, a return vehicle, and more infrastructure automatically, of course, means more cost. But it also means a larger entry, descent, and landing system, which is quite a challenge. A larger entry, descent, and landing system compared to a permanent settlement mission. And developing that technology will also cost money. Now, the problem with a commercial venture like ours and money is that you need to give the people who give you the money, the investors, you need to give them a return on their investment. And there's a number of things that investors look at. There's the actual percentage of return, there's the uncertainties, and I believe that with a return mission you will include additional uncertainties in, for example, the development of the larger entry, descent, and landing system, so uncertainties in the timeline. Higher amounts of money, so that's more money with a later return on investment makes it, well, basically squared as difficult to raise your money for your return mission. Not a problem if you're a government, but if you are doing it in a commercial way, that's definitely a problem. And so many reasons, so many good reasons not to go back. And then there is, of course, the most important reason from my point of view, and that's exploration. If you if you want to explore a whole new planet, then you need a lot of man-hours. So why send humans on a vacation to Mars if you can send actual workers who can work there the rest of their lives? Because that's what they want to do. They don't want to go back. They want to stay there the rest of their lives. So why not use that? Plenty of arguments, I think, for permanent settlement, and I really look forward to having some of your feedback at the end of my presentation. So the other thing I want to give you some more details about for our plan is the trip. How do you get to Mars? Well, we've designed our mission around a rocket that is not existing yet. We've designed it around the Falcon Heavy. Our the first time we will need the Falcon Heavy is 2022, so that's very well within the timeline that SpaceX is currently setting, and even with the delays that will probably be there, that still leaves plenty of time. If it doesn't make it, then we can always postpone the date for the launch. And there's other rockets in development, and there's other rockets that exist, but of course the cost of a Falcon Heavy is really attractive, and I think it's a very important piece of technology that you need for human missions to Mars. So we have assumed a throw mass of about 13,000 kilos to Mars, which gives you an entry mass of about 10,000 kilos when you arrive at the red planet. 10,000 kilos, that's more than anything that's currently done. And one of the big technology developments that are still needed for any Mars mission, including ours, is scaling up the entry, descent, and landing system. Fortunately, NASA has been doing that for quite some time already. For example, the Mare rovers had an entry mass of about 820 kilos, and the Science Laboratory had an entry mass of about 3,300 kilos. So NASA felt confident to take a step of a factor of 4 from 800 to 3,300 in the entry, descent, and landing system. Really impressive. Step of 4 is, of course, the step in Viking was bigger. It was from 0 to 1,000. But after that, this was the biggest step that was taken. So from 3,300 to 10,000, which is our entry mass, is a factor of 3. So that is something that NASA does have experience with. And we have discussed this with experts, and they say that it is probably 10,000 kilos is probably still feasible with the same technique, so the same strategy that NASA has been using for the current mission. So with a parachute and probably retro rockets and not a sky crane, or certainly not airbags, of course. So that's cargo, sending cargo to Mars. Now, sending humans. Our plan is to assemble a small, cozy little space station in low Earth orbit, consisting of one of our landing modules and a small transit habitat, a small space station, and 2 propellant stages. So the crew will activate the propellant stages and go from low Earth orbit to Trans-Mars injection. All that can be launched with Falcon Heavy rockets, and probably one normal Falcon rocket for the crew. And then you're on your way to Mars. Now here, again, the permanent settlement has some interesting aspects. Because it is permanent settlement, we only need that transit habitat once. So it's 230 days of travel to Mars. And we considered, what if you don't recycle water? If you don't recycle water, and instead bring all the water with you, then you don't have your water recycling system, which is quite important if you don't carry all your water. You don't have the backups. That's a very important system, so you need some backups, you need some spares. It needs power. Power needs cooling. So it's a system that really adds to the complexity of the transit habitat. What if you don't bring that, and instead you bring tanks? And for 230 days, you need about 2,500 liters of water. If you, of course, you do need to condense the water from your atmosphere, so that gives you a little bit extra. But if you bring all the water, you have 2,500 liters of water, and that is actually, coincidentally, I think, just enough to shield, to create a hollow water tank in which you can create 4 very small bunks where your crew can sleep, so they're protected against gravity, so that the water is on the outside of your bunks, and that they can use as a radiation shelter in case of a solar proton event. And such a 25 centimeters of water is a really good protection against that. So we don't worry too much about the solar proton event, except that it's really not fun to be in that small confined space for a prolonged time, but it's better than being fried. So these kinds of simplifications are extremely important for and are possible because of the permanent settlement aspect. Now, then they arrive at Mars. The nice thing of our design is that the entry, descent, and landing system, we will try to use a system that looks as much as possible like the one that we will have used for all the cargo missions. So it will have a track record of between 7 and 9 landings, and that is for space missions quite good. Hey, I wouldn't get into a brand new plane if it had a track record of 8 or 9 or 10, but for space missions that's pretty good. Don't forget that Neil Armstrong and Buzz Aldrin landed on the moon with a track record of 0. That was the first time that the moon lander was on the moon. It was the first time that it took off. Of course, it had been tested on Earth, but it had not been on the moon. It had not launched from the moon. Completely unacceptable in the current day and age. And another reason why I think that permanent settlement is so important, because how do you test your Earth return system for Mars to Earth with sufficient a sufficiently high number of tests and with high enough fidelity to make sure that it really looks like what the humans are going to experience? So they use the transit habitat on the way to Mars. They unfortunately can't land the transit habitat in the 10-ton landing system, so they only land the capsule that was attached to the transit habitat, the lander that we've been using for the cargo modules, and they land on Mars. Now, the disadvantages of landing on Mars compared to landing on Earth is that on Earth there's aircraft carriers or helicopters and medics standing by. So what's very important is when you land, you will feel terrible because you've been in 0G for a long time. Suddenly you're in a gravity environment. Although it's only 40%, you will still be probably nauseous when you move your head, etc. So we have to make sure that our crew can stay in the transit habitat, in the lander module long enough to get rid of those symptoms, which is 24 hours is usually enough. Then they will still be weak, but they're on a planet with a weak gravity, so that's okay. And then they can move to the outpost, and there they can recover further with the habitable outpost that is waiting for them. So I hope that gives you a little bit more detail about the transportation system that Mars One is planning to use. A few small updates about the progress at Mars One. We have found that despite the fact that there is sometimes negative press about Mars One, we have found that more and more people are getting enthusiastic about what we're doing, and that's really good. So we had a pretty high amount of bad press in March and April, and actually in those months 2 companies approached us. One I can already share with you, one I cannot. The company that I can share is Björn Borg. It's a sportswear and underwear brand, and they are doing a fashion show. It's not very well known in the US. It's quite big in Europe, especially in Holland and Sweden. It's huge. They are doing a fashion show for their next fashion line, for the 2016 fashion line. that's inspired by Mars One. And to some, maybe the scientists say, well, come on, a fashion brand. But don't forget that Mars One is not only about science. Of course, we want to do science on Mars, but Mars One is much more about grabbing the average person's attention and say, we're going to Mars. And that's where getting a fashion brand like that interested helps a lot more than telling them which science experiments you're bringing. So we are very excited about that. It's a medium-sized fashion brand, but what's very interesting is all the big brands know them, because in those markets they're really nibbling on the market share of their competitors, their big competitors. And so their competitors know about Mars One, and they will see what effect the Mars One community, the Mars One story can have on a fashion show like that. And we hope that it will inspire bigger brands to attach to us. There's a second one. I can't tell you much about it, but it's another cultural connection. And I'm really glad about that, because it shows that Mars One is not only of interest to engineering and science communities, but it's of interest to everything. And that's what Mars exploration should be about. It should not be about the engineering and the science. It should be about humanity moving forward, taking on new challenges, and going to new places. So I'm very excited about the cool things that are happening about Mars One. And I hope that next year I can bring you even cooler news. I hope to be here again, Robert, if you will invite me. Thank you very much.
So I had a kind of two-part question. First off, today you presented the plan that's been on your website for 3 years that we believe was shown to be infeasible last night. And last night, when you were challenged with that infeasibility, you said that's not the plan. So my question is, what is the Mars One plan? And when do you intend to present evidence for the feasibility of that plan? The second point is, you mentioned that this one point of failure for a return mission. I'm curious how you can say that when a return mission could last maybe 3 years and you're expecting to keep people alive for the rest of their lives with launch after launch after launch after launch. How does a return mission have more failure points than a mission that has an effectively 50 to 70 year timeline?
So Mars One is at the pre-phase A stage of a mission plan. And every plan starts there. Every plan starts at the drawing board. There's an initial plan, and as time moves on, you create more details for your plan, you move it ahead, you get more detailed results, you adjust the plan to the results until you have a plan that you can solidify, that you can fix, and you can start having aerospace suppliers build, test and design your equipment. Mars One is looking for funding to take that step, and well, we talked about it yesterday. As soon as we have that funding, then we can start detailing out the plans, fleshing them out in more detail, and we will, as we did. I'd like to have some other people ask questions too. We can talk after the meeting with more questions. So we're.
That's what you just said. That is
Yeah.
So the second, what was the second part of your question? Risk, yeah. So of course, as who pointed out it was the guy from Google. What was his name? Vince. As Vince pointed out, a reliable transportation system to Mars is extremely important. If Mars One achieves in setting up the unmanned settlement before the humans go, if we have done 8 successful missions that have landed on Mars successfully, because only then can we send the first humans. If all that is in place, then I believe that there is a reliable method of transportation to the surface of Mars, and that's what you need. Then you can keep sending either spare parts or resources that are needed to keep the humans alive, or new technologies such that they can produce those systems on the planet to have a more sustainable way of staying alive. Thanks. We can talk more after the session. Don't worry.
Question.
Hi. Hi. Yes. Just briefly, do you have any idea what the range of ballistic coefficient you expect for your cargo and human landers? Is that known to you yet?
And no, one of the first studies that we want to issue now is a study, probably to Lockheed Martin, on designing the best entry, descent, and landing system for the specs that we know are in place. So we know that we will be designing it around the Falcon Heavy, and we will ask Lockheed Martin to come up with the best design for landing as much as possible with as low as possible cost on the surface of Mars. So those kinds of details will come from that study.
Do you have a commitment from SpaceX to use their Falcon Heavy?
Well, we have. I've been there a couple of times. They have been to our office. We're in good contact, and it's very easy. You pay them, they get you there.
So be it.
Thank you very much, Mr. Lansdorp. If you would
Thanks
like
a lot.